section 3. Loving it. Ross helping us celebrate. We're talking about inscribed angles. Loving inscribed angles. What are inscribed angles? Inscribed, that means that it's drawn on the inside. So let's take a look here. We have a circle. If I draw an angle on the inside of the circle, ta-da, that's an inscribed angle. Another way to think about it is that the vertex is on the circle. Okay, so what's the first theorem we're going to learn? Well, the measure of an inscribed angle is half the measure of its intercepted arc. So we have to figure out what is the intercepted arc. Well, in this particular example, the intercepted arc is the arc that's formed by the end of the, what do we got, the rays here, the segments. Okay, the arc between on the inside of the angle, that's the intercepted arc. Okay, well, the measure of the angle is half the measure of this arc. So, for example, if this arc were, I don't know, say 80 degrees, then we know that the angle would equal 40 degrees. Okay, it's that simple. That's all we have to do. So let's do some examples. All right, first example, we have, what do they tell us? They tell us the measure of this arc here is 129. And this arc here, and they're adjacent, they're touching each other, so I can add them together, and doing that will give me 210 degrees. That's the entire arc, okay, if I look at it the whole thing. Well, we know that a circle has 360 degrees, so if I take away 210, that's going to leave me with a 150. So, what do we have here? This arc equals 150 degrees, and we know that the angle that's the inscribed angle that intercepts that arc is equal to half of the 150, so x here is going to equal 75 degrees. It's half of 150. Done with that one. Easy enough. Let's look at the next one. We have a diameter, okay, that cuts the circle in half, so I'm not even going to look at this half of the circle. All right, I'm just dealing with half the circle here, and that's 180 degrees total. I know that because the angle is half of the measure of the intercepted arc, so if this is 45, that means that the arc must have been 90, because the angle's half. Okay, and if the entire semicircle is 180, let's call that x. That means that x plus 90 has to equal 180, or for that one, we're also going to get x equals 90. Easy enough, right? Let's put another, what do we have here? This is another example. Why don't you try it? Pause the video, do that one by yourself. Go! Alright, so hopefully you worked it out. I did a little bit differently than you might have done it, and I want to do that just to show you what we can do here. I put x is the angle, and so the arc must be twice the measure of the angle, because remember, the angle's half the arc. Alright, so if this is x, this is twice x, so I just put a 2x there, and I wrote a very simple equation. 2x plus 112 equals 180. When I solve it for x, that's going to be the measure of just the angle, and we're all done. I get 34. Easy enough, right? Bang! Let's crank it up a notch then. What do we got? Algebra now. So 4x minus 15 is going to equal half of the intercepted arc. So the angle is half of the measure of the intercepted arc. So now it's just an algebra game. Can we distribute a half? I hate distributing a half, but you know, sometimes we got to do things we don't like. So what do we got? 4x minus 15 equals 3.5x minus 7.5. All right, I'm going to subtract 3.5x from each side. That's going to give us 0.5x. What do we got? Plus 15 plus 15. What is that going to give us? It's going to equal 7.5. If I divide both sides, I get x equals 15. Done with that one. All right, easy enough. Let's do the next one. Now, here we see two adjacent arcs. What I'm looking at, let's actually look at the angle here. So the angle we're looking at is right here. All right, so 15x equals half of whatever this arc is that we're intercepting. Should we show the arc? Here's the arc. It's that arc plus this arc right here. Okay, so can I find the sum of those two? Let's do that right now real quick, and we'll do that off to the side here. So 11x plus 7 plus 17x plus 3. What does that all equal? Well, we get 28x. All right, so we got plus 7 plus 3, that's a plus 10. All right, so this entire arc from here to here equals 28x plus 10. So let's write our equation now that we have. So 15x equals 1/2 the measure of this arc, which we figured out to be 28x plus 10. Alright, so let's do a little distributive property. 15x equals half of 28 is 14, and we get half of 10 is 5. If I subtract 14 from each side, we get x equals 5. Done with that one. See? Easy enough. So easy. Why don't you try the next two all by yourself? But I'm going to warn you, look, They don't want you to solve for x. They want you to solve for the angle. Ready, set, go. Pause the video. Okay, first example. Well, we have to set it up. I see that it goes through the center. This is the diameter here, GE. So that means that this semicircle, or this half of the circle, equals 180 degrees. So I add these two arcs together, 16x plus 4 and 27x plus 4. Add those two together. Here they are. It should equal 180 degrees. Simple algebra goes through it. You should get x equals 4. Hopefully you did that okay. But remember, we want to find the measure of angle GEF, which is this angle right here. So this angle equals half of the arc that it intercepts. That's half of 27x plus 4. So I take my x right here, 4, and I plug it into the x right there, and I get 112 degrees for this arc right here. Okay, so that means half of that is 56 degrees. Easy enough. Next example. This one's a little more straightforward, where we have 8x plus 1 is equal to half the measure of the intercepted arc. So then you distribute the half, which, by the way, you could multiply both sides by 2, and that would get rid of the half, and you double this side, gets 16x plus 2, and the algebra becomes a little easier. But nevertheless, work through it. You get x equals 5, and then you have to plug that back in because they want the measure of angle RQS. You get 41 degrees. That is awesome. Hopefully you did that one okay. Now a corollary. Corollaries. Now what is a corollary? Well, corollaries are very important. They're so important, in fact, that Mr. Sullivan's parents named him after corollaries. His middle name's actually Larry, so if you put Corey with Larry, it's corollary. And what is a corollary? Corollary is something, it's like a direct result of a theorem. So the last theorem that we just talked about the inscribed angles being half the measure of the intercepted arc. All right, so let's look down at this example. I'm going to explain this corollary here. So if we have an inscribed quadrilateral, well, an inscribed means that it's touching at every vertex, okay? Well, what does that mean? Well, let's look at the opposite vertex here. We have these two opposite ones. The angle at S, okay, cuts off this part of the circle, while the angle at L, let's use a different color, cuts off this part of the circle. Hey, what did we just do? We created the whole circle. We have the whole circle here, so this all equals 360 degrees. All right, well, the angles are half the measure of the intercepted arcs. Well, 360 degrees worth of intercepted arcs are right here. All right, so that means that the angles must be half that, so half of 360 is 180. So what does this all mean? It means that if you have opposite angles in a quadrilateral that's inscribed in a circle, they're going to be equal to 180 degrees because the whole circle is incorporated into those two intercepted arcs. Blah, blah, blah. All right, here's the corollary. Opposite angles of quadrilateral inscribed in a circle are supplementary. So if you have a quadrilateral, opposite angles supplementary, let's go with it. So 13x plus 4 plus 16x plus 2 is all going to equal 180 degrees. Okay, that's the supplementary part. So we can add these two together. What do we get? 29x plus 6 equals 180 degrees. If we subtract 6 from each side, we're going to get 29x equals 174. And then we get, what do you get? X equals 6. If I do my math correctly, x equals 6. All right, so in these examples, they're going to ask you to solve for x. They might ask you for an angle, and if they do that, then we'll just plug it back in. What do you think about that? Well, let's do one a little bit more difficult. Okay, clean that up a little for you. We're going to use our corollary here that we know the opposite angles in an inscribed quadrilateral are supplementary. So the first thing I can do is I can write down, here's some opposite angles right there. They're not congruent to each other, but they're opposite angles. I can write down 10x plus y plus 100 equals 180. So if I subtract 100 from each side, I'm going to get 10x plus y equals 80. And then if I subtract 10x from each side, I'm going to get y equals negative 10x plus 80. You're like, Mr. Kelly, why'd you do all that? Well, let's look. When we set up our equation, we have an x and a y. Guess what happens when you have an x and a y? You can't solve that without another equation. So here's the second equation we get. So we know these two angles are supplementary because they're opposite angles, quadrilateral inscribed. So what are we going to get here? We're going to get 2y plus 94. All right, plus 9x plus 14 is going to equal 180. So if I combine some like terms, we're going to get what? 2y plus 9x plus 108. Let's subtract 108 from each side. So 2y plus 9x equals 72. All right, so that's the equation I get simplified after I say these are supplementary, add them up to 180, and we're all good to go. We are almost done. Remember substitution. So y equals this mess right here, negative 10x plus 80. We need to plug that in right here for the y. All right, do you think we can do that? I'm confident. I think we can do it. So 2 times y. I'm going to use different colors so you can see where it comes from. Negative 10x plus 80. All right, that is 2y. Now we got to write the rest of the equation here. So plus 9x equals 72. So let's start doing some distribution here. We get negative 20x plus 160 plus 9x equals 72. Can we combine these two? I think we can. Negative 11x plus 160 equals 72. We're going to get negative 11x equals negative 88. After we subtract 160 from each side, you get x equals 8. I know I went through that very quickly, but if you can pause the video, you can kind of work through it on your own. All right, so x equals 8. If I plug an 8 into here, I'm going to get a y equal to 0. Remember what you have to do? You take your x equals 8 and you plug it back in. I'm going to plug it in right there to the x, and I'm going to get negative 10 times 8 is negative 80 plus 80. That's going to give you y equals 0. So that's our answer there for that one. We have to use substitution. That's the system of linear equations. We are all done with these examples. Okay, what we're going to do is break out the conceptual elixir here. I know that we're getting along in this video, but we're going to get through, and what I'm going to do is I'm going to take this inscribed angle here. If you notice, the inscribed angle never changes. Like if I were to measure it, it's always the same. It doesn't matter where the inscribed angle is on the circle. Look at it. It's always the same measure. It doesn't change, and it doesn't get obtuse, doesn't get more acute. Okay, now what happens as I bring C closer to D? I want you to think about that before I do it. What happens as C gets closer to D? What's going to happen? All right, so let's do it. C's getting closer, closer, closer. What do we have right there? Okay, so is the angle changing? No, it isn't. But when we get to point D, what we have is no longer do we have a chord going through the circle. This ray right now becomes a tangent. All right, so it is like an inscribed angle where the vertex comes up to one of the endpoints of the ray. Amazing. Raise your hand if that just confused you. All right, put your hands down, everybody. So the next theorem we get, because of this, we put a little picture there so you can remind you of what's going on. The measure of an angle formed by a chord in a tangent is half the measure of the intercepted arc. It's basically the same thing. It's the same thing happening, except you're bringing C closer to D. The limit as the distance approaches 0. That's crazy. All right, so find the indicated measurement. Assume lines that appear tangent are tangent. So that appears tangent right there. So what do we have? You don't need to look at this part of the picture. What we're looking at right here is we have a tangent and we have a secant, and we know that the intercepted arc is 160. So that means, let's call this x. That means x is going to equal half of 160. Half of 160, that's 80. It's that simple. Are you serious? I'm serious. Next example. Well, this is just working backwards. So if 65 is half of x, let's call this x, okay? Then multiply both sides by 2, you get 130 degrees to be x there. Seriously! Let's do some more examples. If we put some algebra in there, 45 degrees equals 1/2 of 22x plus 2. All right, so if I distribute the 1/2 like a good boy, what do we get here? Subtract 1 from each side. 44 equals 11x. 4 equals x. Everybody see what I'm doing here? Okay, I'm just looking at this and setting up a fancy equation and then solving it. How about this? 55x. All right, well, this gets a little bit complicated. We can do it two ways. You can either find this angle right here. It's 180 minus this. Okay, that's kind of ugly. Or this arc here is 360 minus the other side, because remember the whole circle has 360 degrees. So if we take 360 and minus 55x, that's going to equal this arc right here. So the way I'm going to do it, the angle 16x plus 6 is going to equal half of the measure of the intercepted arc. All right, so let's do a little bit of algebra here. We're going to distribute the half. So 16x plus 6 equals 180 minus, what's half of 55? 27.5 x. All right, so now if we move everything to one side, what do we get? So if we do plus 27.5x on both sides, we're going to get 100. And, no, we don't get 100. What are you talking about, Mr. Kelly? Don't be crazy. Subtract 6 from each side. 174, you're going to get x equals 4 here. When you divide each side, it's that simple. I mean, as long as you know how to set it up, you're good to go, right? Is that it? Is that it? You try to. Pause the video. Pause the video. Hey, why are you not pausing the video? Don't make me call Joe. You know who? Joe Mama. I'll call her. Pause the video. First example, 280. That means the remainder of the circle has to have 80 degrees. All right, so that arc equals 80. So the measure of the angle equals half of the arc. That's the equation I wrote. Angle equals half of arc. Half of arc is 40. Minus 40 minus 40, you get a 0. Divide by 2, divide by 2. X equals 0. All done with that one. Next one. All right, so what do we get here? Look, we got to find the measure of the angle. How many times can we point to this? Remember, don't just solve for x in this example. Here's the intercepted arc they give us. All right, so that equals 1/2 of, you have to add those two together. So that's where my equation comes from. X plus 112 equals half of the sum of the other two angles. So now it's just a little game of combining like terms. I love that game. That's a fun game. So what do we get? X and 2x is 3x. And what do we get there? A 4, and we get 224. That's fun. So now what? Check this out. I'm going to pull out my math magician hat. I'm going to multiply both sides by 2. What's that going to do? Why is Mr. Kelly doing that? Because look, that 2 will cancel that half. I don't have to deal with fractions anymore. That's the only reason I did that. I don't want to deal with fractions. I got time for that. So we get 3x plus 224. Notice how they cancel, but you do have to use parentheses if you're going to do that method. Let's subtract 2x from each side. You're going to get 224 equals x plus 224, and you're going to get 0 equal to x. But you have to plug it in. They want TDC. So if you plug in a 0 for x here, then let's write it out. So we're not being lazy. The measure of angle TDC equals 0 plus 112. And you don't, do you have to write that? Well, you are communicating exactly what you're doing. Oh my God, the bell just rang. I'm a bomb holder. It scared me. You are communicating exactly what you're doing to the grader, so you can get your partial credit points, especially on those tests. I know you don't get it on the mastery check, but you do on the test. Okay, what I'm going to do, this is like a special after video production. This is like extended feature on the DVD, because I heard a lot of students have a problem with this. So I'm going to go over it. Number 7 off of the practice. This is the exact number 7. Let's look at it. They give you an angle here, LSR, and they tell you it's 2x plus 102. I know this is half of the intercepted arc. Now the arc goes from L through Q all the way around to R. Okay, so that intercepted arc is twice the measure of this angle. So let's figure that out. This equals twice the measure of the angle. Okay, so there's the measure of that angle. Well, look, now we have 3 different arcs, and it equals the entire circle. We have this one here, x plus 70. Then we have 2x plus 86. Then we have this entire arc, which is 2 times 2x plus 102. Because this is a complete circle, they all add up to 360. Okay, so I combine some like terms after I distribute. What do we get here? Basically, x is going to equal 0. All right, so that is the problem. It's number 7 on the practice, the same one. They want you to find angle LSR, so you got to plug that 0 in. You're going to get 102 degrees. Okay, easy enough. For number 8, it would be the same, except this arc EF here would be 2 times 17 plus 5x. You can add them all up, set them equal to 360. So that's how you do those two. I know they're not in the notes part, but there I just went over it, so there should be less problems. Hey, I'm going to leave you a little bit of Ross when he can't figure out his angles. This is Mr. Kelly and Bomb Holder. Remember, it's nice to be important. It's more important to be nice. So,
all right, okay. Here we go. All right, ready? Yeah. Turn. Okay. Turn. Turn!
I don't think we can turn anymore.
I just don't think it's gonna fit.
Oh yeah, well come on, up, up, up,